Okay, in this video we're going to continue reviewing just some of the algebra skills that are going to be useful for us in this section as we work with identities. So if I have something like sine of x times sine x plus cosecant of x, okay, it might be easier sometimes to have things in this form, which we call factored form, where it's two things that are being multiplied together. Other times it's going to be easier to have things multiplied out. So we want to know how to do both things. So if I wanted to have this multiplied out, I would just be distributing that sine x. So sine x times sine x would give me sine squared x. And then I'd have plus sine x times cosecant of x. So that's just doing the multiplication. Now, once I've done that, if all I was asked to do is do the multiplication, I've done it. But I might notice this is sine squared x plus this is sine x times 1 over sine x. And that's going to cancel out, so I get sine squared x plus 1. Okay. All right. Now, sometimes I'm going to need to multiply, and I'm going to have more than one factor on the outside. So I could have something like sine x plus cosine x times 3 sine x minus 2 cosine x. Okay. Now, in this case, I still need to distribute, but I'm distributing each term here to each term here. So the sine x gets distributed to both terms there, and the cosine x gets distributed to both terms there. And of course, when it's 2 terms times 2 terms, we have this nice mnemonic device for keeping track of the 4 products that we'll get. FOIL, f is the first terms, so that's going to give me 3 copies of sine squared x. O is for the outsides, that's minus 2 copies of sine x cosine x. I is for the insides, that's plus 3 copies of sine x times cosine x. And L is for the lasts, and that's going to be minus 2 copies of cosine squared x. So these are the 4 terms that I get. And now if I take a look, these guys are like terms. They're both just some number of sine times cosine, so I can consolidate those. So we'll have 3 sine squared x plus 3 sine x cosine x minus 2 cosine squared x. Okay. Very often, although it's not guaranteed, when you FOIL things out, just like the O and the I come together to make that OI sound, very often the outsides and insides will be like terms, and so you can combine them. Okay. So that's multiplying things out, which sometimes is what we're going to want to do. Other times, we're going to want to unmultiply things out. Rather than having just one big result, it's going to be simpler to have a bunch of little pieces connected by multiplication. And unmultiplying is better known as factoring. So let's suppose that I had cosine squared x plus cosine x times sine x. Well, if I take a look here, I've got these 2 terms. They have something in common. They both contain at least one factor of cosine. So we would say that cosine here is the biggest thing they have in common. It's the greatest common factor. And I can pull that out. Because essentially what I'm doing here is I'm saying that's cosine x times cosine x. That's cosine x times sine x. So it's like I just distributed a cosine x to these 2 things. So I can factor that out and say that's cosine x being multiplied by cosine x plus sine x. Okay. Not necessary to write this middle step unless you find it helpful. Okay. Always when you're factoring, most of us, including myself, find it's easier to multiply than to factor. Okay. So if you're ever unsure, you can always check, if I were to distribute that cosine back through, would it take me back to what I started with? If it does, I factored correctly, and if it doesn't, I factored incorrectly. So this is an example where I was able to just factor out one thing. Very often when we're factoring, we're going to have a situation where we have 3 terms. So maybe something like a cosine squared x plus 4 cosine x plus 3. And I want to try to factor that. Well, when we have 3 terms, we call this a trinomial. And the way we're going to factor this is I always first of all look to see if there's anything all 3 terms have in common. If there's a greatest common factor, I want to pull that out first. Here there isn't. Okay. So I'm going to hope that this is the result of foiling, and I'm going to try to unfoil. Although I actually sometimes call it unfloying, because when I'm foiling, I usually follow the order of the letters. I usually do firsts and then outsides and then insides and then L. Okay, and then last, so that I've spelled foil. When I'm unfoiling, I'm going to follow this order. Okay. So I'm going to say I'm hoping that this is the result of foiling. In order to get cosine squared as the first terms, I would have to have a cosine x here and a cosine x here. So I'm figuring out what those first terms were. Now, in order to get a 3 here, I'd need to have 2 numbers that multiply to give me 3. So often off to the side, I'll sort of write down a list of what the possibilities are. This happens to be a very short list. There are a 1 and a 3. Now, I do need to be careful. That's a plus sign. That tells me that my numbers have to have the same sign. If I have a positive here and a positive here, when I multiply them, I'll get a positive. But if they were both negative, they would also multiply to give me a positive. So I actually have 2 possibilities just looking at the last. It could be plus 1 and plus 3, or minus 1 and minus 3. To see which sign it is, I look at this one. I need to get a total of 4 copies of x. That's a positive number. 4 copies of cosine x. That's a positive number. So I'm going to want my outsides and my insides to be positive, but the outsides will have whatever sign this has, and the insides will have whatever sign this has. So it looks like a plus 1 and a plus 3 should work. Let's just double check. Cosine squared, 3 cosine plus cosine gives me 4 cosine, plus 3. So we have successfully unfoiled that one. Notice in figuring out the signs of the numbers, I looked at this sign first. This told me that they had to be the same sign. And then this is what I looked at second, and that told me that they had to both be positive. So let's try a couple more of those. With any of these, you're more than welcome, once I put the problem on the board, to pause the video, try it on your own, and then tune back in and see if our answers match. Okay. So let's try sine squared x minus 8x I can think. I'm sorry, sine squared x minus 8 sine x plus 12. So again, I'm hoping that this is the result of foiling. The middle term is the most complicated because it's the outsides and the insides together. So I'm just engaging in a little strategic procrastination and looking at the easier parts first. In order to get a sine squared, I'm thinking I'd need a sine x and a sine x. Okay. Now, in order to get a 12, I've got more possibilities this time. So I'm just going to write them down in pairs. 1 and 12 would multiply to give me 12. So would 2 and 6. And so would 3 and 4. Now, because this sign is positive, these numbers are going to have the same sign. Okay. And that essentially means that when I combine them, I'm going to keep that sign the same and just add their absolute values. And I want to get negative 8x, so this tells me they're going to both be negative. Okay. So I'm looking for the pair that when I make them both negative, I combine them and I get negative 8. Well, negative 1 and negative 12 would be negative 13. Negative 2 and negative 6 would work. That would give me a negative 8. So I'm going to have a negative 2 and a negative 6. It does not matter, by the way, where I put the negative 2 and where I put the negative 6. Since each factor starts with just one copy of sine x, if I put the negative 6 here and the negative 2 here, that's equivalent, because when I'm multiplying, order doesn't matter. Okay. All right, again, I can do a quick check. Sine squared minus 6x minus 2x gives me minus 6 sine x minus 2 sine x gives me minus 8 sine x, and then a plus 12. Okay. So notice whenever this sign is positive, these numbers are going to have the same sign, and it's going to be whatever sign that middle term has. Okay. Let's try an example where that last number is negative. Let's say we had tan squared x minus 4x, minus 4 tan x minus 5. Okay, so I'm hoping that this is the result of foiling. So if it is, in order to get a tan squared, I'd have to have a tangent of x and a tangent of x. Then I need numbers that are going to multiply to give me 5. This is another nice example. It's a very short list, 1 and 5. Because this sign is negative, they're going to have opposite signs. Okay, so one of them will be positive and one of them will be negative, so that when I combine them, I'm going to be subtracting their absolute values. Now, I'm happy about that because the difference between 5 and 1 is 4, which is going to match that middle term. But now I need to see, if I want to end up with a negative 4, I'm going to need the bigger one to be negative. Okay. So I'm going to want the 5 to be negative and the 1 to be positive. So I can write a plus 1 and a minus 5. And again, since each of those is going in a factor where the first term is exactly the same, it's just tangent of x, it does not matter which factor I write first. Okay. Let's try one more. So far, the coefficient in front of our squared term has always been 1. Let's just try this one. Let's say I've got 2 secant squared x. Oh dear, I had the example a minute ago. Let me look at my notes. Minus secant x minus 15. There we go. And I want to view this as the result, as the result of foiling. So again, I'm going to start by looking at my first terms, but now in order to get 2 secant squared x, I'm going to need one factor to have 2 secant x and the other to have secant x. So they don't start out exactly the same. Okay. Then for the 15, just focusing on the absolute value, to get 15, it would have to be 1 and 15, or 3 and 5. Okay. And because this sign is negative, they're going to have opposite signs. Okay. So one of them's positive and one of them's negative, which means when I'm combining them, I'm essentially subtracting, and I want the result to be negative 1. But now, I'm not building that negative 1 just out of these numbers, which is pretty good because neither pair has a difference of 1. Okay. Whatever number I put here, I'm going to be doubling. And whatever number I put here, I'm going to be multiplying by 1. Okay. So, looking at this, because I'm trying to get negative 1, I'm kind of thinking it's likely to be this pair of numbers, the 3 and the 5, because 1 is kind of a small number, and these are pretty far apart. So I'm thinking I'd get a big number if I used numbers that were so far apart. Looks to me like just using a little bit of trial and error, if I were to put the 5 here and the 3 here, I'd get 10 secants minus 3 secants. That's not so good. But if I put the 3 here and the 5 here, that's 6 secants from the outside and 5 secants from the inside. That difference is going to be 1. Now, since I want the difference to be negative 1, I want the bigger product here, which is the 6 secants, to be negative. So I'm going to want the 5 to be positive. Okay. Notice here, it doesn't matter whether I write this factor second or first, but it does matter that the negative 3 goes with the 1 secant and the 5 goes with the 2 secant. Let's just double check. 2 secant squared minus 6 secant plus 5 secant is minus secant. Minus 15 Excellent. So we've successfully factored. Okay. Now, what we've done in these first two videos is just review some algebra that we're going to be using in these things. Some of you probably are like, oh, great, feel really comfortable with this. Happy to be factoring again. I haven't factored in a while, but I like it. Others of you might be saying, oh, factoring. Never been that good at that. If that's the case, I'm not spending a lot of time in the videos on that because I wouldn't spend a lot of time in class on that, but I would extend an invitation, which I will extend to you now, to visit office hours and take advantage of tutoring if you need to brush up on factoring. It's always the case that there are a number of students who struggle with that, and the fact that I'm not spending a lot of time in the official class time videos on that doesn't mean I don't want to help. It means that that's a prereq, so I don't have a lot of time in class to spend reviewing that. But that's what office hours and tutoring are for. So if you need to take advantage of that, by all means do. I'm more than happy to practice factoring with folks and help you brief up on those skills. Okay? Next video, we'll actually start applying these skills to prove some trig identity.